as well.
Yeah, sure,
Okay,
sure. Okay, cool.
sounds good. Thank you so
Let's.
much, Rohit.
Okay, then I'll remove you for just 2 minutes. So, guys, yeah. So, yeah. Hi, Kamish.
Yes.
Yeah, you can hear me, right?
Yeah, I can hear you well.
Okay,
You're good,
cool.
Rohit.
Yeah, we are live right now. So good morning to everybody. Mostly the people out there in India. So few people might be from outside the India as well, as we have the other speaker Anna. So this is our fourth meetup on JetBrains, and this event is
Yes.
specifically around two sessions.
Yeah, I can hear you
The
well.
first session will
You're good,
be
Rohit.
on improving cloud native application density with Quarkus. So all the audience can post their questions in the comment box. After conversation, we'll be having Anna with the second session. So Kamish, you're good to go. I'll just remove myself.
Thanks, Rohit. Hello, good morning, everyone, and wherever you are. So, I think mostly if you are from India, it's pretty good to meet you. I think probably I would have seen you many people during the jugs which we had earlier. So let me go ahead and quickly present my screen. Probably I share my screen now. So I hope people should see my screen now. I'll just get into my presentation mode, and then okay. So how do I share this one? Okay. So I'm pretty new to this platform, so I might be a little bit slow on this. So let me go and share my screen. I'll say my entire screen so that I don't have the hardship of flipping the Chrome browser. I think I'm sharing right now. And then let me go and present my screen. I hope everyone could see my screen, right? Um, Rohit, could you see my screen? Hello?
Yes, Kamish, I can see.
Okay. So that's great. So this is what we're going to talk about today. So probably on Quarkus. That's going to be our talk of the day. So where you're going to talk about a shrink create your Java application, right? So probably there were a couple of sessions which I gave on Quarkus earlier during the jobs in Bangalore. So this is going to be more centric around cloud native. Why we need Quarkus for cloud, right? That's going to be the talk of the day. And I have put on my email ID, and then the link to the deck is right here. Quarkus Java shrink ray. Probably I've made some updates today morning for session. I'll be uploading that soon, so you can just get those links from there. And then all the commands that I'm going to use today are from the Quarkus tutorial. So don't worry if you miss my commands. Just follow me what I'm trying to understand saying about Quarkus. That's more than enough, because you can go back and try all those commands that I do on my screen when you go back to the tutorial. It's pretty detailed. It gives you one step by step, and then it makes you easy to do as well. I share the tutorial link as well during my talk. All right. So with that, this is pretty much about myself. So I'm just I actually probably can just also reach my Red Hat email ID as well. So probably you can just email me there, or if you are a Twitter user, you can follow me on Twitter. I have put on my QR code here. You can just scan the QR code and then DM me if you have any questions. I have put on all of my Twitter handles as well. So one of the things I like to share with you people is that I just launched by MOOC 3 weeks back. That's a Knative cookbook on serverless. So that has a lot of recipes built into that for everyday serverless development as well. So which includes most of the predominantly on Java side. So which obviously has Quarkus component. I'll be starting with the demo soon and show you what I mean by that. And even the examples from my demos can be found in my cookbook. So this cookbook is absolutely free. You can just click the link right there, dn.dev/knative cookbook. You can go download this cookbook from there. The only thing you might need is, since it's going to be, go to our developers.redhat.com, the BU which I work for. So if you want to go there, you just need to register yourself to download the ebook. The ebook will be there forever, so you can just go download there, and then there's multiple recipes as well there. All right. So that's pretty much quick intro about myself. Let me go and see the hero of the day, the supersonic subatomic Java that we are going to talk today. So this Java, the site is there, quarkus.io. I'll be sharing the sites, the guides, and everything in the flow of the session. But one of the things which I'm going to start with, like, let me go why we need Quarkus, right? Because though this is more Quarkus cloud native centric session, but what I thought was, like, let me give you a quick intro about what Quarkus does to the Java world, so that you know like why we actually need Quarkus. All right. So let's go here and then do some demyths, right? A few of the things which is untold truths about Java and containers. All right. So if you take traditionally for cloud native application, people started to move to Node.js or Golang or any other more faster and performing languages, right? So one of the reasons why they did not go for Java is because they thought that Java is slow. Java is kind of slow for you. Java does this thing. Java is fat, etc., etc. All right. So, but when you go back and analyze why do we have all these things, right? For example, basically the points that I have listed on my slides here. So when you start any Java application, right, there's a bunch of overhead that is involved, right? One is that I need to scan the class path, then I need to load the jars from the disk, which is kind of my dependencies, and do some annotation parsing, build the metadata that is required, and then also add some JIT, right, to the code. That I need to do dynamic optimization and compiling and all these stuff. But one of the critical facts that's going to be your boot up time, right? The startup overhead is more towards your boot up time. Why my Java application boots slow. All right. But the second point, if you see, there is more of a memory overhead as well, right? The number of classes loaded on heap, the number of classes on off heap, and number of classes on meta space. When you put everything, all these three things together, that's what your resident set size is, right? So what I mean by resident set size is that the actual memory that your application is going to take while running this application. This becomes super crucial for cloud native. We'll see why soon. But if you see, let's take a very quick example, right? To explain this stuff more, for example, let's imagine a case like I'm starting Hibernate based application. All right. So it's a JPA application. So what basically we do is, like, for a JPA application, we'll be having, let's say, a persistence XML. All right. And then there's the persistence XML will have a lot of entity classes and other stuff. So for to load and parse a persistence XML, we load a SAX parser. All right. So once we load a SAX parser, then what happens is that once a SAX parser is loaded, so we also go and scan the class path as well. All right. So we scan the class path and we say, okay, everything is good on the class path. And then this is what I need to do. So we just go and scan this class path. And then once I scan the class path, I kind of establish the database connection and do all of the stuff, create those database specific entities and all these stuff. So just for a point, if you pause and think back, so why can't we do all these things at build time rather than at runtime? because that's where what happens is, like in this case, if since I'm do traditionally I've been doing everything at a runtime, what basically happens is that everything gets loaded into your memory, and once it's loaded into memory, so like heap and half heap can be swiped up during garbage collection. But the problem is the metaspace, most of the case metaspace never gets GC'd. Because of that, there will be a residual thing that will be writing forever, which will be kind of eating your memory. All right. So that's what we did with Quarkus. With Quarkus, what we did is like, okay, let's think back, right? Let's say the same scenario. So instead of doing everything at runtime, why can't I push few of the responsibilities to build time, right? So this is needed because I need to have an agile, scalable, and faster business reactivity, right? I say when I go to cloud, the first thing I expect that when I say app start, the app should be started. All right, that's something which is there in cloud because I don't know the spikes when it will come. I don't know the things which when I have to react faster, when I have to scale, when I have to scale up and scale down. We'll see more examples about that. Because of this, what needs to be done is like I need to do something super quick on the cloud, right? So when for doing that, so if I move few of the responsibilities from runtime to build time, and then in that case, what happens is that your application should boot up faster and quicker. All right. And also, like since there is going to be a lot of activity which has been done at build time, what basically happens is that the number of classes that get loaded at runtime is also going to be less, which is going to make your memory size smaller and shareable, and obviously increase your density as well. All right. So if you see this example here again, so let's quickly go and demonstrate on this for you. So let me go and share my screen. I think I'm still sharing my screen. So let me go to my command line, or even I go to the IDE. Okay, I'll just go create your first thing, right? So to do this, Quarkus is very easy. First, let me go and take you to the Quarkus site. You can just go to quarkus.io. So QARKUS.io. So this is a site where you can go to load Quarkus. Right here, quarkus.io. When you go to the site, so the Quarkus thing is loaded for you. We have the get started guides. We have the complete detailed guides of all the features that we right now have in Quarkus, including some advanced stuff as well. You can just go read those guides as well to get familiar with whatever the context you want to work with Quarkus on. All right. So and then you can also go back. Let me go to my thing on the Visual Studio. I think we're also coming up with other IDE tools as well, but right now, since Visual Studio Code is quite popular, so what I'm going to use right now is Visual Studio Code IDE because in fact I'm a great fan of IntelliJ as well. So don't take me wrong. So but what I'm doing right now is that for demonstrations, I feel I just need to use this because I just want to show code neatly and cleanly. Yes. All right. So and then for that matter, if you see my font, I will show still I'm at JetBrains font. If you see this is JetBrains mono font, right? Because I've been using IntelliJ for quite long years, and then still carried things into Visual Studio Code, but still I cannot see myself in a different font. Okay, so that's what I did with this as well. In all my IDs, all my command lines, everything is using JetBrains mono font. It's a super font. I greatly suggest all you guys to use that as well. Okay, coming back to the context, right, for what we have to do right now. So the one important thing what you need to do for Quarkus is that if you go to the Visual Studio Marketplace and then search for Quarkus, you should see one Quarkus thing which is already installed. I think I already installed this. This is the only little thing that is required on your machine apart from JDK 11 and Maven 3.6.3 plus. So obviously, if you don't have Maven 3.6.3, obviously your system will complain you that I'm not having Maven. All right. So and then what I need to do once I install this, so to create a Quarkus project is super easy. I can do from command line as well, but I'm showing an example from the console. Let's go and call this and just say Quarkus generate Quarkus project. This is what I'm going to do right now. And then this is going to go and talk to the API code.quarkus.io and then kind of get your stuff. I just say I want to use Maven as my build tool. And then let me change my package name, Kamesh S, dev.kamesh S. All right. And then I'm going to give an app name. So let me call this as demo app. That's what I'm going to do right now. I'm going to build on top of this. And let me give a version at 1.0. Okay. And I'm going to have one resource, which is a hello world resource. I'm calling it as greeting resource that's going to be generated. Now, what happens is now it will ask you that what all the plugins that is required, right? So, and then we say like, I don't want any other plugins. I just want to use one little thing, which is already chosen. And then it goes and asks you where you want to generate. Okay. So I'm just going to create a new folder here, CC days demos. Okay. And then I'm going to put it here. right? And it's going to open up your thing. So what basically this plugin does is that is just it's a bunch of Maven command line, so which is going to generate and scaffold a project for it. That's all it does. It doesn't do anything more bigger than this. All right. So let me hide this one as well so that it's not interfering. And then let me go here. Once a Quarkus, let's go and find out what we have in this project, right? So for example, we have a bunch of Docker files generated. We'll come back to this after some time. And then you see this is a hello world resource which got created and probably an empty property file. So I'll just put this here because we'll be using something here as well later. All right. So this is what it got generated right now. And let's quickly run to see how fast we go, right? So the first thing I had to go and do is like, let me go to command line. I'll open my command line here. I hope my screen is well and clear. And then I say mvnw clean package. Probably I can skip the test because I don't have anything on the test here. All right. So now I'm going to skip, right? So one of the few things which I want to go back to my slides and tell you is that, so when I go, see the build is done in 5 seconds. If you go back to my slides, one of the things is that with Quarkus, what we're trying to achieve is that we're trying to say we are 10x smaller and 100x faster. That is absolutely a requirement for cloud. We will see more about that, why we need that. Okay. So if you see this, I want to show you that we are 10x smaller. Let me go to let's go here, make it a little bit more bigger. Sorry. On my thing right here, I clear my screen, make it a little bit bigger. And then I say ls-ltrh and then say target. Now you see this is a runner jar which is going to be used, which is kind of taking you 340K, right? So this is what your actual size of the jar that's going to be run, all right? And then we're also saying that we are 10x faster, right? That's again another 100x faster, right? So that's what we're going to say for the Java applications, okay? So let's go here and then see what we have. And then I say java-jar and then say target runner.jar, and you should see the Quarkus is started in 0.613 second. Okay, so this is a Java application which has been started in 0.613 seconds. All right. So when I go and do a little bit more, one more thing, what we also do as part of Quarkus is, right, we also have Graal VM as an enabler for us to achieve those 30% extra speed. Okay, so if you imagine this, all the things that's done with Quarkus making Java faster has nothing to do with Graal. Graal is just an enabler. All you have done doing is that only during the Quarkus augmentation that happens during your compilation phase. That's a build phase. To put it in another word, you can imagine Quarkus is like another build tool, but a smarter build tool, right? It's not something like your Maven, Gradle, or any other stuff. It just say build Java C and then make your classes. Instead of that, it goes, scans your class path, makes studies of your metadata, creates your Java indexes, and does everything that is required to boot up your application blazing fast. Okay, that's the reason why I call this as another smarter build tool compared to the other build tools which is there in market. Okay, so and anyways, the other build tools are required here, but I'm just saying that Quarkus could be imagined like a build tool. Okay, so probably I can take a quick pause here to see if there is any questions that is from the people before I proceed further. Is there any questions from the audience? Maybe I can just take a quick pause here to see if there is any questions. Otherwise, I can just keep moving. No questions? Okay, if there is no questions, let me go further. All right, so let's do the next step, right? So as I told, Graal is just an enabler for you. What I'm going to do is, like, for going back to the same one, I'm just going to say clean package. But only thing is that now I'm going to compile this on a native mode. Okay, so now it's going to generate me a native binary. I have a profile to build the native one, which is automatically scaffolded for you. Just you need to add the profile to do a native compilation. So I'm just going to do a Graal compilation right now, adding to the extra thing. So what it's going to do is, like, maybe it takes a bit more than normal build time because it has to do a Graal compilation. So only thing which we do right now is that we say, okay, we are doing the Graal compilation here, and then I'm going to try to go and create these projects for you as well. So what I'm doing right now is I'm just going to do a native build thing for you. And then you see this native build is being done. And then one of the crucial things which you do as part of Quarkus is that we go past them these right options. Okay, one of the important things for Graal compiler is that we have to go give them the right options to build. Otherwise, your build is not, your native binary is not going to work the way it's expected. So that's the extra stuff which you do. And if you see this, the input for this is your demo runner jar, right? The augmented jar which we created in the previous step. That's going to be the input for this, which means that Graal is just adding an enhancement to my speed of my Quarkus, right? So let's wait for a few seconds. It should be taking a minute or so to build to be completed. Just once it's done, then what we go ahead and do is like we kind of go and build this image and then run the image and see how fast it is, right? Last time we saw that your JVM mode of Quarkus started in I think it's around 0.613 seconds. Now let's go and see how fast this one starts for you. All right, so let's give few seconds, and anybody, if you have any questions, Rohit, please pop it on so that I can answer the questions, and then keep moving. All right, so the build is done. So as I told you, the native build takes a bit of time. It's 1.3 seconds. That's what the build takes, and the more the dependencies you add, it will take more time, because considering the amount of the class path thing and the thing need to done. Okay, so let me go and do this. If you go and see this ls-ltr h target again, as you see, there is one executable, the native Mac OS binary that has been created. If you're running on Linux, then it's going to be a Linux OS binary for you. So this is what got created for you. And then this is size of 27 megabytes of your thing. And then now when I say target run, and then I say demo app, runner.jar, I mean, not jar, just runner. This is going to start Quarkus, and then it says that it has been started in 0.016 seconds. Okay, this is your Java application which has been started so fast. Okay, that's going to be your native mode of the application. All right, so this is what becomes important, right? If you have seen two factors here, right? Let me go back to my slide and start explaining more about this. Okay, this is what is a very basic introduction. You have more details on the Quarkus tutorial. You can go to the Quarkus tutorial and start checking this out as well. But before that, let's go back to my slides, and then let me go and where I am right now. And then I say, so we saw two things right now, right? We saw it's 10x smaller and then 100x faster, right? Because when I go into native mode, I'm getting super speed. And then even if I go to the normal JVM mode, it's comparatively speedier than the other frameworks, okay? So, but it's more than this, right? More than this, it also gives you a developer joy, right? I'll come back to this developer joy point in a second. So what it basically does, it like I can do development, build, check on the fly, right? What I mean by this is, let's go here, back to my thing, and then I say, okay, let me go here, and then I say clear maven w compile. I just need to give one task for this. Any maven task should do. Quarkus dev. When I start Quarkus right here, what happens is Quarkus right now it's running in a development mode. All right. So what happens also, like this little tools which I have, the VS Code extension for Java. I think what I can also do, right? Let's say let's do this, right? I'm just putting this another thing here. I say curl localhost 8080, and then I say hello. All right. So this is going to give me. Okay, I'm sorry. There's a bad with the spelling. All right, so we got this hello, right? So right now, what I want to do is like I want to change this to a variable. All right, the first thing I'm going to do. Okay, I call a text call as greeting here. All right. So once you do greeting, you can also pull this one. This is a VS Code extension, Quarkus extension. So you can also open your thing from locally, right? You'll see that as well in a second. And then I say config property. Okay, this is a micro profile config, Eclipse micro profile for config, which is already there as part of Quarkus core. So I can inject properties. Okay, I say string greeting. Okay, and then I need to give this one another one, right? It's here saying, okay, why did this start now? Okay, I say a name, and then I should say which one I want, right? I usually, the good practice is that I usually prefix my thing with my name. I just say I need a property like this, right? And then what I need to do this now, what happens is that now when I go and say greeting from here, so there is no greeting here. I say this, and then now what happens, and I go and put this greeting here. Okay, and then I need to set a value like say hello, okay, or something like hi. All right. So now what happens is that this is what is going to be printed for you right now. I can open this from this URL, or I'll also do it from curl. I'll do it from curl because that's the reason why, where I can show you the recompilation, right? So when I go back and say hello again, now what happens, you see Quarkus is recompiled and gave you the new updated one. I'm not stopped my server is still running, okay? And then I'm going and giving you a command like saying hi, right? So this is what happened to me right now, right? So this is, if you see this, this is not only recompiled your classes, it also loaded your application properties. Adding fuel to fire, I can also do add an extension. I'll come back to extension in a second. So there's a lot of extensions about this. So another dependencies that you add, let's say I want to add this is a cloud native talk, so I'm just going to say I want to add a health check, okay? So I'm just going to add this health check this, and then small dry health check. Once I do this, basically what happens is like, let's go and watch this out in this command line. You will see my Quarkus application is going to be reloaded, meaning to say it's detected some dependency change, which means that it has to reload your application classes. All right. So now you see earlier we saw just only one thing, right? CDI and Quarkus and Kubernetes. Now we also see the REST EC and small dry health as well. All right. So when I go and say health here, now I should get the health, right? This is everything is happen on the fly, right? I'm not stopping and stopping my server. I'm adding my dependencies, I'm adding my application properties, I'm updating my Java class, and everything happens to be on the fly. This, it's not only with this, we can also go to an extent of making this working against your databases as well. Okay, so probably that could be a different talk altogether, but I want to consider the to be very complacent about the time. I just want to constrain this talk only to cloud native. Okay, so let's go here. I think you see this, I can do all these things. This is what exactly I mean by developer joy, right? I don't need to stop my server. I can go on an iterative mode of development. I can develop I see what's happening. I can change my properties. But one good thing about Quarkus reloading is that it will not reload immediately you do the change, right? Because you understand that when I do a change, the change will be a cascading change. I go from one particular class to another class to another class to another class, and finally I say it's complete. Then I know when I need to do, that's what the curl I do. Now I know I have to test it. I just do a curl, and there I get this thing back, right? When the thing is reloaded and show you a new stuff. All right. So this is what I mean by developer joy. And we also have a best breed of frameworks, right? Which has been included in Quarkus. Okay. To do this, let's go back to my command line, and I'll show you this one. So let's go to the Quarkus project here. So let's go by demos, and then I say temp slash cc days demos, and then demo app. And then when I say, let me make this a little bit bigger for you to see. When I say MENW, or MEN for that matter, Quarkus list extensions, I'm just going to list you a lot of extensions, right? For example, let's go and see what all extensions we have. So we'll be having, right now we have lots and lots of extensions, which means that I can add these dependencies to my project and start developing the application. All right. So if you see this, there's a lot of camel stuff here. And then we have health checks, we have Google Drive, we have Amazon extensions, A3, we have lots and lots. Okay. So for example, let's say I'm a database, I want to develop a database application. Then I can just do just these things, right? I'm just going to grab only the ORM and JDBC. We have a bunch of stuff which is already there. I just need to go and add these stuff and start developing my application. That's going to be so easy like that. Okay. So for example, let's say I want to go and add these extensions. When you list the extensions, you saw the command by which I can do the extensions like this. Or also if you saw from the extensions tooling system, like from the Quarkus VS Code extension, we are able to add those extensions as well on top of this. Okay, so I can do any kind of this. I can just go add these extensions to start building my application. All right, so that is what I talked about, this plethora of extensions we have. Like we have Vertex, Hibernate, REST Easy, Camel, etc., right? Infinispan and Kafka as well. All right. So, and then you also have Kubernetes and OpenShift extension. These are more like cloud centric. How do I build my container image? How do I deploy my image? We'll see an example soon about how do I build and push the same Hello World application into a native deployment. All right. Let's go and do that. Okay. So let's go here and then go to my application. Now what I want to do is like, I want to go and deploy this application into cloud. Okay, I have an OpenShift cluster right now running for me, which is a Kubernetes cluster for you. For me, for example, in this case, I'm just going to take this application, this demo app, and then going to deploy this demo app right here, right? So how does Quarkus helps you to do that? So Quarkus has an extension called as Kubernetes extension. I can add this Kubernetes extension to Quarkus, and also have a bunch of other extensions to do your build your container images. For example, I can use Jib, I can use Docker, I can use S2I, which is more OpenShift centric stuff, and build my Java application as a container and push the application into cloud. That's the most crucial thing you want to have. All right. So let's go and see how we can do this and come back to the slides, because the build and push takes approximately 3 to 4 minutes. So let me stop this one, and I can also probably close this one as well. So when I add extensions, right, I said like I need to have a Kubernetes extensions. I need to add all these extensions, right? So that's what I did. So when I go here and then say add extensions again, so you should see a command right here. So which says that me and add extensions. I say Kubernetes extension. I want to add a Kubernetes extension here, right there. Okay. And then I want to have small health we already added, and then I want to have Jib because I want to do a container image. I had a Jib, I had container, and then I say enter. Now we'll see this is the command that's getting executed here. If you go here, see this command. So Maven Quarkus add extension, blah blah blah, and then to my POM XML, which means end of the day the extension does nothing and just adding your dependencies. Okay, let me close this one for a second and then go scroll this one down. So you see this, there's a container image, Jib added, Quarkus, Kubernetes is added, and then you also have the small RAI thing is added here as well. All right. So when I build my image, right, so we have the extensions added. I'm not going to change anything on my class. So now what basically happens is that when I add the extension, so I need to tell you what image I need to build. I usually, when you do it in a Docker container image, I say Docker build, and then I say a tag name and all these stuff, right? These are all driven by properties because Quarkus behind the scenes uses an framework called as Decorate. I'll just putting that here right there. Let me see if I got, okay, this is a framework which is being used behind the scenes that is used to do a build, generate your manifest, etc., from a Java application. You can go and watch this. This is also as part of the resource link which I put down there. So that is what is getting used behind the scene, but it requires some properties to be put. Okay, I'm just going to copy these properties here. It's going to go here and then say to my property file. I'll just make this a little bit more bigger so that it's visible. And then I say to you, okay, the container image should use a registry called as square.io. And what should be my base image? So this is the OpenJDK base image, official base image from Red Hat. So you can use this image as your base image. Is more secured, more easier. And then what also you can do is like which repository I need to push to and what should be the thing. And let me change this flag to 2.0. I'll tell you why. Okay. Or any tag name which you want to give. So what basically I'm telling Kubernetes in this with these properties is that go and push the image to my registry, which is right here. As demo app, you see this demo app here. So this is my Quay.io. You can use Docker.io, GCR.io, Amazon the content registry. You can use any registry you want. I'm using Quay. And then I saying going and push. I already pushed when I was doing the demo rehearsals. I pushed 1.0. That's the reason why I changed that to 2.0. All right. So I'm just going to say go and push this image 2.0, which should be your tag. What should be a repository, what should be a group, right? Group is basically the user ID that which we provide, right? End of the day, these translate this particular thing, translate all these properties, 4 properties put together. I mean, these 3, let me move this a little bit more here and then say the base image. When I translate these 3 properties, these properties will basically become like this, right? Quay.io / my image name / demo app, and then my version of the image. That's how it translates to. Okay, so that's how these properties does. And then I can also, I'm trying to say do a build when I do a clean package of my application, which is a Java task. When I do a Java task, also do my image build. Okay, that's what I'm trying to say here. And then not, so this is okay. If you don't want to push, you can make it to false, but we want to push in this case because I want to show how to deploy that as a Kubernetes app later. And then that's what you want to do with push. You can say false when you're doing testing and you want to just to stay with the local, right? This work with all your need is like you need to have a Docker locally running, Docker for Windows, Docker for Mac, or Docker for, I mean, even Docker in Linux, anything you need. I just need a Docker so that it starts compiling that stuff as well. In fact, I can change those build engine as well. If you want to use Podman, I can use Podman as well, but I'm not going to cover that. If you go to the Kubernetes extension and then Kubernetes guides in Quarkus.io, which I showed earlier, So this is a place where you can go find out all your extensions. Here the guides will show you all the thing, right? This is a detailed explanation about how to build a Quarkus image and all this stuff. You can go there as well. All right. So what we're going to do right now is that I'm just going to say, okay, I have this image right now, so let me go and say build image. I'm just going to clear my screen, and then I'm going to say Maven clean package, and then I say D skip test. I don't want to skip test. I can even run skip test as well, but just want to save time. I'm just going to create skip test, right? So I'll just do the start the build, because as I said earlier, this is going to take some time, so that let's allow it to do while we flip back to our presentation and then talking more. All right. So I'll just take a pause before I get to my presentation to see again if we have any questions. We saw how we build this image, but what becomes so important is that I want to take Java to the cloud native world, right? That's my goal of this particular conversation is. So let me take a quick pause here, maybe few seconds, to see if there is any questions. Rohit, if there are any interesting questions, please do pop it on the screen, so that I can see the screen, or you can read it out as well. So anything is okay. Since I'm in a presentation mode, I'm not able to see the window, the chat window, or your pop-up window, so you can read out the questions, or we can take the questions at the last.
Yeah, Kamesh, I have popped up the question on the screen. So there's a guy who is asking, Quarkus is a build. Where will we add the dependencies?
Which I think, can you come again, Rohit, if you don't mind?
Yeah. If Quarkus is a build, where will we add the dependencies?
The dependencies basically gets added to your POM XML. So whenever
Okay.
I did extensions, right? For example, like whenever I added extensions, let me go to my Visual Studio screen. Okay, we have done the build as well. So the build is done quickly in this time. Let me go here and show you the screen. When I did the Quarkus build, right? So basically everything I do, let me close this for a second. Everything I do is get added as an extension right here. Okay, if you see these extensions, so we added Kubernetes extension, we had health, we had jib. So all these things got added as your dependency here. So that's what your command is as well, right? When I say add extension, when you go to my command here, so let me go up. I think I should be having it somewhere here. Okay, you see this here? So this is going and adding the extensions to your POM XML. Extensions are basically nothing but your dependencies, like Quarkus dependencies. Okay, so what I mean by Quarkus dependencies is that, so see, there are a lot of dependencies, like you have Hibernate, you have something else, even small try health could be a common microprofile dependency. What we mean by Quarkus dependency is that each dependency that we want to add to Quarkus and achieve the benefits of what Quarkus is giving you, 10x smaller and 100x faster. In order to for you to achieve that, what basically we need to do is, like, we need to create them in a form of an extension. Okay, the extension is super advanced topic. What basically does it that as a dependent, as a framework developer, let's say I develop a framework called a small dry health, right? I'm just taking an example of that. When I do that, I know what all things will be done at runtime, what all things can be done at build time. Okay, I know these things, and then there is a structure in which I need to create this extension, rebuild the jar, and then give it to Quarkus. When I give that, then Quarkus is know what all things I need to do at build time and what all things I need to do at runtime, and then uses that. Okay, there's a detailed guide. If you go to quarkus.io, let me unshare my screen for a second. If you go to quarkus.io and if you go to the guides, and there is a detailed thing, guide about extension. Let me go here. Where is it? Extension templating, extracting. There is an extension, writing extensions, right? If you see this writing extensions guide, so it gives you how you can write here. You can bring your own dependencies, the jars as well, in a Quarkus style, right? Which means there's not going to be any internal build change or anything like that. You cannot use reflection because that's more a Graal restriction than Quarkus restriction. So you cannot use a reflection and all these stuff. You need to only understand our classifier application, what all things I can do at build time and what all things I can do at runtime. I hope this explains more. If you have more questions, please feel to drop me a note. I can give you more detailed explanation as well.
Sure, Kamesh. So, we can get on to the next questions like later on once you complete your session.
Okay, great. So let me continue this. I have few more things to show for you before I can take a few other questions as well. All right. Let me go here and then. So what I mean by this is, like, so we saw that initially, what I mean from Java to a cloud native journey, right? For example, I started Java initially in days like when I started Java 20 years back, like it was like Swing was the biggest attraction, right? I wanted to show those windows. It runs in Unix, it runs in Linux, it runs in Windows, it runs in Mac OS. It was running in everywhere. So that's a big thing which happened to us. After that, the another big shift for us happened was when serverless and JSP was launched. We are able to go everything client server, and Java was one of the backbones for doing this client server application deployment, right? So that's where we had JSPs, web-based applications, and all these stuff, which still makes sense even till date, right? But now what we're trying to do with Quarkus is we are trying to take Java to the next level, right? We say that Java, let's go to cloud native, but we have some hiccups before we do that, right? So, but the first thing is that we saw that it's cloud native and container native, which means that Kubernetes is native. What I mean by this is that we saw when I add my extension, I was able to do the container build. And then let's go and explore the application in a second as well. We have the manifest also generated so that my application deployment to Kubernetes is going to be super easy, which means that Java is Kubernetes can work together in tandem so easily and so nicely. Okay. So, but the thing is like for cloud native, so application to be cloud native, we need more, right? The core topic of the day was how to increase my density, right? I'll talk about density in a second. But what basically happens with that, we need all the open source framework. What we had today is like they might be either cloud native only, or they might be only microservices only, or they might be only serverless, right? But what we did with Quarkus, what we made sure that Quarkus is for open source stack for writing frameworks or writing application that is for cloud native as well as for microservices as well as for serverless. Okay, we want to cater all these categories of the typical cloud native architectural styles, and then we say, okay, all these application Quarkus can be used one framework which could be used to do all the build across all these applications. Okay, that's a core motto when we started to do apart from the very important motto of making it faster, quicker, and then smaller as well. So why I need this, right? So why I need this is because if you go back to the first slide, which talk about the Java story, right? What basically happened is that the application density of Java becomes lesser and lesser and lesser. Okay, because I'm fatter, it's huge, and then it slow starts because of that. What happens when I go to a cloud-based deployment of Java application? If you see the application in these three things, like I have node 1, node 2, and node 3. The node below is just a compute node. And then I have a Node.js application deployed. I have a Go application deployed. And if you see them, they are small and tiny. They boot faster. Because of that, what I'm able to do is like within a particular compute node, I was able to accommodate a larger set of applications, right? More and more applications, which means that I can have a quick scalability and I need the application to be scaled. But whereas if before Quarkus, if you saw the Java application, even now, if you're not using Quarkus, or that could be any other framework as well, but just saying that if you're not using Quarkus, your application still become fatter and also boot slower, which means that my density at the particular cloud level is going to be very, very less. Okay. So what it means to me that's adding O to a cloud native application is that, for example, if you deploy any application within cloud, right, what basically happens, a lot of other things get shared. Okay, you have a lot of thread sharing, you have memory sharing, you cannot share CPUs, and then finally, more than that, most of the application which you deploy in cloud will be having a quota attached to it, right? Without quota, we will not do anything within cloud, right? For example, when you have all these things happens, what basically happens is that when you have something like this, your application is going to go for a boom because I cannot scale further. So I have only 4 requests. I have to cater, let's say, around 10,000, 20,000 requests. I just have 4 instances of my application. Okay, so this is a crucial problem. This is where I talk about density. When I'm able to increase the density, when I'm able to, and the containers are going to use very less memory, because in cloud we can share storage, we can share CPU, we can share everything, but you cannot share memory, right? When I have more memory given to this, I can have more memory left in the host, which means that I can spin up more containers, which means that my application density is going to increase even with a Java-based application. All right. So in this context, I want to show you one little thing. Let me go to my application console and then show you. I had deployed an example. Let's say go on side by side. And then I have a Spring Boot application, I have a Noded application, and I have Noded is Node.js, and I have a Quarkus application. Let me go and quickly see the monitoring dashboard of my application, and then see what's the memory usage of these applications, right? For example, this is Quarkus, which is going to have taken you 40 MB of RAM, and this is Node.js. In fact, this is more than Node.js, right? Node.js has taken 43, Quarkus has taken 40, And then you have, if you see this, this is going to be a container memory of a Spring Boot application, which is taken 120 MB, right? So I'm not saying Spring Boot. See, there's no hard feelings. The Spring Boot is bad or nothing. So I'm just trying to compare the story, right? What we did with Quarkus to make it much easier, much slimmer in the whole world, right? Even Quarkus has a Spring Boot compatibility. I can take my Spring Boot application and I can build and run as a Quarkus Spring application. There's no big difference, right? The guide, if you go to a tutorial, the tutorial has a guide for that. I'll just walk through the tutorial at the end and then after the session. So when I talk about bandwidth, so this is what the memory usage, right? When we talked about quotas, especially if you're on cloud, this becomes super crucial. This becomes very important when I want to increase my application density, right? So if Quarkus has just taken you 40 MB or something, if you see 41 to be, we just round it off, and then in fact it is much better than, it's better than even Node.js, right? Node.js has taken 43.1, and then Spring Boot has taken 230. It's keep increasing, right? It keeps increasing and decreasing, right? So, but if you see Spring Boot has taken 236 MB, right? Which means that approximately, if I put, I can have 6 times Quarkus deployed at the same space as what Spring Boot is taking right now, or any other cloud native Java stack, right? Not necessarily to be Spring Boot. It can even be Tonte. It can be anything else. So it can be any typical Java application which is not Quarkus. In that case, what happens? Your memory increases, which means that I'm just going to say, like in this particular space where Spring Boot is taking 240 MB, I can put 6 Quarkus applications there, which means that my application density is going to increase. All right. So that's what. So instead of this, I'll be seeing 6 more. I mean, here I'm just showing hotspot here, and then I can just go and increase this further as well. All right. So, and how does this is achieved, is there are multiple things, not just making it faster or quicker. There's also something which we need to change from the paradigm shift of how you do your application, right? Even with Quarkus, from moving from imperative to reactive based application, right? It unifies imperative and reactive model, which means that for you to have more application density, I should have more concurrency as well, right? Which should serve one particular pod, which we talk in Kubernetes world. One pod should serve so many number of requests, which means my application is going to take a lot of scaling, right? Which means that it needs to have lots and lots of concurrency as well. So if you see with Quarkus, we made imperative and reactive together, right? Which is one framework which you can use. You can naturally use your application to be imperative and reactive as well. So there are examples on the tutorial. I'm not going to talk into detail because this is going to be its own session. Probably I'll talk with Ganesh and Hari and Rohit and all of this to see, like, if we can schedule one imperative and reactive session later next month to see where I can talk exclusively on this particular stuff. All right. So I'm going to stop talking more. So what I'm going to, and once you share this site, I think you can see the where you can talk about, join the community here. So the Quarkus IO is a site where you can go. There's a Zulip chat where you can participate, ask your questions. Please feel to do so. So the the guys are very responsive. We can get this answer. You can also follow us on Quarkus IO. And my friend Alex, he's written a book right now. I think that's getting released soon. I think you can just go grab the early release of Quarkus cookbook, which talks about various recipes like what the Kennedy cookbook we had. So you can also do a Quarkus cookbook. You can just go grab this copy from there. These are all part of the slides. When you get the slides, you can just go to these links. And I have also put down the resource, right? So this is what the Quarkus tutorial I was talking to you about. So whatever the commands you saw right now, we have a cloud native section for this. We have a basic sections for this. You can also join us at dn.dev/ I think I need to show you those as well. So you can also go to dn.dev/ master. We are running master courses on Kubernetes, Istio, Knative, serverless, Quarkus every month. So the Quarkus sessions for the month was done. So, but you'll be soon opening up for June as well. You can just go there. I'll put those link at the chat so that, like, it could be shared with you people as well. Come register yourself so that you can learn more about what you're doing. And we also have a bunch of resources put on here. So please go and watch these resources as well. And then if you really like my session and then you like Quarkus, then just tweet out today or anytime whenever you're there, just with this tag Quarkus.io and then this hashtag making Java ever awesome. Okay. So before I get to questions, I want to show you the scalability because I talked about density, but I want to show it in real time. So let me go to the quick demo to show that thing. So let me go to my demo screen, demo project here on OpenShift. And then I go to topology here. So what I have is, like, I have a Kafka running in my cluster. So you can just I just deployed Kafka into my OpenShift cluster. Kafka could be deployed using Streamz Kafka. It's another project, Strimzi, streamz.io. So this is the project which can be used to deploy Kafka on Kubernetes so fast and so quick, and it's much simpler and easier as well. So I have a Kafka deployed. So let me go and see what Kafka I have. So let me go here and then say kubectl get -n on the range with Kafka's. So this is going to give me my Kafka cluster. I have one Kafka cluster which is deployed, which is kind of 3-node Kafka cluster that is running inside. You can see this. I have 3-node Kafka cluster which is running there, 3 Kafka replicas and 3 Zookeeper. So this is my cluster which I'm using right now. So what I did is like I told you earlier, as I told you earlier, I can also do a Kubernetes deployment, right? So let's do that first, right? So I'm on this project. I'm on my Quarkus project. And how do I do a deployment? I need to add this property. I not added this property to the property file, but you can do this as well. I just say mvnw -d skip test clean package, and then I say deploy true. So when I do this, what basically is going to happen is that it's okay. I need to set the let me set this thing as well. So my cloud is on GCP. I'm just going to say I have few variables to set here, so I'm just doing that. Cloud profile GCP. I need to set my what is this kubeconfig. People are and just say OpenShift $cloud profile /auth kubeconfig. Right. So I'm on a demo namespace right now. What I'm going to do right now is that I'm going to say mvn w mvn w-d skip test clean package, and go and do a deployment of this application into Kubernetes. What basically happens is that my application get pushed, and once it pushed, it's going to deploy this application here, right? So let me go, and also one another need I need to do is like I need to make this repository is a private repository, so it will not be able to pull it out. So I just go there and see if I disable that. Yes, I've done that. So I can disable this. Quay.io is absolutely free. You can go register yourself as well in Quay.io, and you can pull this out. So what I'm going to do is like I'm just going to do a clean package which is going to build my container image and deploy my image into Kubernetes, right? One shot, one single command. It's a simple command from a Java developer perspective. Is everything is for cloud native. This is what is going to happen. Let's go and see this. So while this runs, what I also wanted to show you is that I'm going to show you another one. So let's say if this demo application is built, it's getting built right now. It's going to change your things, copying the class libraries and everything. So what I can also do is like, so let's go here. I'm going to show you something which is quite interesting for you. This example is in my book, the Kennedy cookbook. You can grab this up from there. So what I'm going to do is like I'm just going to run into my Kafka spammer pod. So this is what I call this. So what basically my application is going to do is like okay, maybe I just don't have this here. So let me go and set this here. Okay. I hope I have the Kafka spammer pod right, and then let me get into the shell here. So what I'm going to do right now is that to show you the scalability, right? We saw that one of the things for the application density is that I have to have my application scale infinitely across, right? Mainly on my cluster. So right now what I did is like I have a Kafka cluster which is deployed as I told you earlier, and have one little application. If you go to my topology, the demo app is deployed here. So there you go. Your application is running right now. So because from the Quarkus extension that was deployed, if you see in this case, I have this eventing hello application, which is a serverless application here. Okay. So what I did is that I just deployed this earlier. So as I said earlier, the examples are there in the cookbook. So don't worry about this. So even so, what this particular thing is going to do is like this is going to scale. What I made sure is that the concurrency of this particular application is going to be 1. Okay, just for the demo sake. Okay. So which means that as much of messages I'm going to pump into Kafka, I'm going to have the scalability of this particular application increased in that fold. For example, if I push 3 messages, then there's going to be three instances of this scaled up. Similarly, five instances. So let's do that. So I have maximum of 100 as a capacity for this. Let me try to do 10 to show you an example here. So let me go to my spammer pod, which basically sends this message here. I just say curl localhost. This is the which triggers behind the scene. I say I want to do 10 messages. Okay. So when I do this, what basically happens right now, there's going to be 10 containers. You see this? 10 containers getting created on the fly to serve your request. Okay. So this is what I mean. This is a Java application which got created, and these 10 applications are kind of created in fraction of seconds. Since a new cluster I created just before a call, so there might be some nodes where the images might not be pulled. It's kind of pulling those images from there and scaling this up. Okay, which means that now I have scaled 10 pods in less than a second, right? That's what the whole case is, right? It's going to capture a requirement. So this is what I was talking about. This particular eventing hello application was built using Quarkus. Okay, so that's what I did. So right now I was able to scale up 100 pods. I mean 10 pods right now. I can even scale up to 100 pods if I want, because that's the maximum list capacity I've given for this demonstration. I can go up to 100, I think, at whatever list, right? But the point is, so what happens in this case is that your scalability is kind of like this. It's like spiked, right? Because I get 10 requests. I don't know what to do with the old Java style of application where we struggle to increase. You see this, all these 10 things are done. Once the requests are done, this is a serverless application, which means that it's going to scale and terminate all your applications. That is saving your cloud cost as well. So now we see I was able to deploy a microservices application. I was able to be a cloud native because one single framework is able to build my container image and deploy my application as well. And the third point is that I also made it serverless because I'm also able to do the serverless scale up and scale down with fraction of seconds, right? This means that my application is going to go infinite, right? I'm just going to have a more increased application density, which means that I have a better performing application, better, not than performing, I should say, catering more requests in this, right? The concurrency is going to be increased. Okay. Before I go to the questions, I want to just do one little thing. I'm just going to say 50 here, and then you should see 50 pods scaling up pretty quickly, right? 10 will do the request, but in this case, it's going to be 50 in this case, end of the day. So it's just going to give me now, if you see this, since the images has been cached, so there has been 30 pods, has been scaled right now, and 34 right now. You see this? So this is the amount of scaling that it can go up to, right? In fraction of seconds, I have all the pods up and running, serving my request, and everything is done, right? You see this? You can imagine this 50 pods, 50 Java application is scaled in less than 3 seconds for you. Okay, that's a speed which you're doing, at which Quarkus is able to scale, right? Which means that I can have more requests scattered and handle more spikes handled. Okay. I hope this sounds exciting to you. If you want to try this example, please do get into my book. I have my book URL right there in the slides right here. And this one, you can just go grab this one and then do this. I can just grab the questions from there and then download this book from there, which has this exact example which you can create in your own cluster as well with using Quarkus. All right. So, and that's pretty much I have to show on demos today. Probably I'll stop sharing and probably take questions if I have anything. Rohit, I'm open to questions. I'm also putting this. If you're using similar to Spring, can we do auto wire on runtime if we add something as extension? Okay, the extension concept is a little bit different here, Shank. The thing is here is that the extension is what we're trying to do is like we're trying to avoid whatever could be done at the runtime could smooth to build, and that's the majority of thing that extension does. Apart from the Quarkus augmentation, which increases your speed of your application. Okay, the auto wire is basically to attach your dependencies, not the extensions, right? Basically, I want to have a bean injected, so that's a CDI, which could also be done. But auto wire basically injects your beans or dependencies, right? Not exactly your jar dependencies, just your application, a class, another class, or something like that. Okay, that's a difference there. Is there any other questions, Rohit? Okay, cloud native. So what is cloud native? So I should say the application when you deploy an application into a cloud, right? Basically, how you build and deploy your application, run them in cloud. Okay, the cloud native has its own characteristics, right? As I was showing in one of my slides, probably once you get the slides, you can see there are a few things which your application has to take care. Point number one is how do I share the CPU, how do I share my memory, how do I share my disk, and how do I scale up and scale down, how do I get myself distributed across my cloud. So these are the few characteristics that this particular cloud native application should be exhibit. Okay, so that's typically what microservices kind of architecture or framework helps you building cloud native applications. When I adhere to microservices architectural style, I naturally make my application to be cloud native, which becomes distributed, talking them over APIs, and then taking care of the conscious, being conscious about how much memory I have, how much CPU I have, how much disk I have, and how do I relocate myself on cloud when something happens. And all these things are taken care when you take off microservice architecture. I think in a way I can call cloud native and microservices architecture are more or less used interchangeably. So externalizing configuration. Okay, I showed you that I can use the typical application properties which could be used, right? But if you're using Kubernetes kind of platform, right, I can have secrets and config maps where I can store my properties and load them as volumes within my pods. Okay, that's possible. I think if you go to the extension, the Quarkus extension, which I have, which I just showed you right now, I'm just putting on the chat to share with people. Rohit, I think it will be great if you can share these links to the audience. I'm just putting my cookbook link here, which is where they can download the cookbook. And this is going to be your Quarkus slides thing. And then this is going to be your Quarkus tutorial one. So dn.dev/Quarkus tutorial. Okay. So all these things talk about this more, and then to be very specific to Venkata's question. So if you want to do configuration, right? Configuration basically, if you go to, let me go and put this one. Okay, I go here. I'm going and putting an exact link for you, Venkata. Give me a second. I'm just grabbing this one for you. So if you read this particular section, I think probably that will explains the case for you. I think. Rohit, I think can you please cross post the chat? I mean, these links to the audience as well, so that they can know this. I think that's the way by which you can externalize your configuration, or I can even talk to a REST API like your config server and then do that as well. That's also possible, but nothing stops you. Any other questions? When it would be work with the latest? I think Raja. I think this actually what we have done with Quarkus 1.4 is that we started to slowly deprecate 1.8 thing. So because if you see the Quarkus projects that you generate with the latest 1.4.2.final, which is a version that is released a week back. So if you use Quarkus, it's by default it defaults to JDK 11, and then the plan right now is that by 1.6 of Quarkus, we mostly will deprecate 1.8, which means that it will be by default will be working with JDK 11 only, right? I think even now whatever the compilation I just now did is works with JDK 14, but I don't use any JDK features. It still uses JDK 11 features. Mostly the support should come soon. I don't think so anything bigger from Quarkus side stops it from working from JDK 14. But if you're using native compilation, then Graal should be enabled for JDK 14. I don't think so it's enabled for JDK 14 right now, because the latest I see is only JDK 11 for Graal. Was there any other questions?
I think Kamesh, that's all we have questions.
Okay, so I think Rohit, I think I have few links pasted to you on the chat. So
Yes.
so we are also having the DevNation master courses, which has been running every month. So I would probably I can share the link on this thing where you can go and register yourself. If you go register yourself, you'll be able to get a live stream URLs where we'll be having sessions across the day, right, on all multiple languages. You can just share that as well. And then I have
Sure.
put down the link for the cookbook, which you can download, the Knative cookbook from where you saw the Kafka demo, which I showed right now. And then I put on the Quarkus guides, which helps you to get started with Quarkus as well. And the Quarkus tutorial, which is going to be just continuously maintained by us. So we keep updating for every release of Quarkus. It talks about all the stuff which I just now spoke to you, including from the basics. So which means that you can start Quarkus from the basics as well. Okay,
Okay.
I strongly sorry, Rohit, go ahead.
No, no, no. Go ahead. Go ahead. Actually,
So
we
I
had two
strongly
more.
encourage you to go to these links and then get to them. I'll also share the slide deck with you, Rohit, offline, so that you can share it with the community as well.
Sure. Kamesh, like we have two more questions. I'll just pop it out.
Sure, sure, sure. Please. So why deprecate? So me to say, see, Pradeep, I think that's a good question for you to ask on the Quarkus Zulip chat, because you can get the authenticated answers from the engineers. From my perspective, it's like it's too much of maintenance for us, right? For example, like if we see that you want to maintain JDK8, which doesn't mean that it will not work with JDK8. 100% will work with JDK8. Okay, no problem at all. The only thing is that by default we want to move to JDK11. That's the whole idea. But the only thing is like I don't have an authorized answer for myself. Probably I would strongly encourage you go to the Zulip chat for the Quarkus IO, which I have that in the chat. I mean, let me put that link also on the this particular stuff, where you can go ask this question, where you get the authorized answer from our guys. Okay, so I'm going to copy this one. uh, I think Rohit, I posted the Zulip chat link, which is a community link. Probably I want the people to ask questions there on specifically the deprecated stuff, so that they get the perfect answer from the engineers why they did that.
Sure, I have pasted that. We have one more question.
Can any jar be added as a dependency in create a native app? Okay. I think Tinku, I think this could be done. Any jar could be added. So only thing is like the recommendation from our Quarkus side is that we don't want people to mix the external jars with Quarkus and non-Quarkus jars. The simple reason is being that you don't get the benefits of what you're giving, right? Because the loss of benefits happens when Quarkus does that augmentation, right? Where it does during the build, it does an augmentation on your jar to see, like, to extract the bytecode, to do further few other stuff which is required. So if you can add a jar and create a native app, provided there are few gotchas in that, like the Graal VM does not support native image, I mean the reflection out of the box, so which means that your application will fail at native time if it's using reflection. And there are also some rules which is required for you to add external resources, for example application properties or xmls or anything that you need to add to be in the class path. There are few gotchas that you need to follow for it to be added. So these are something which Quarkus does out of the box for you. So it's always better that if you are planning to use the jar, try to see if you can make a jar as a Quarkus jar using extension, and then it can be added naturally. I strongly recommended that approach than trying this way.
Kamesh, I think we have like answered all the questions.
That's great.
Mm, yeah.
I hope the session was useful. As I told you earlier, like please feel to have ping me on Twitter or GitHub or LinkedIn, or drop you an email. I have my email on my slide deck. Once you get the slide deck, you'll see my email as well. You can drop me a questions on that. I'll be happy to answer your questions. And probably looking forward to see you all in a net another cloud native virtual meetup sometime next month. Until then, it's thanks from Kamesh, and thanks Rohit, and thanks everyone from CodeOps for getting me here. And have a great day ahead and stay safe.
Thank you, Kamesh, for your wonderful session today. Like, definitely we'll catch up soon and we'll have another learning session in the next month. So, thanks a lot, Kamesh. Okay, then uh, we'll have our next section. Meanwhile, like guys, you can post your questions in the comment box, or you can directly reach out to Kamesh over Twitter. We'll be also sharing his Twitter handle, where you can directly ping him or like post your questions. So thanks a lot, Kamesh, again.
Thanks
I'll,
everyone. Bye bye.
okay, bye. Okay, guys, then we have our next speaker, Anna. So Anna, I'll be adding you to the stream.
I'm here.
Yeah. Hi, Anna.
Hi everyone.
Yeah. So I think you were there throughout the session when Kamesh was speaking. So
Okay. Okay.
yeah,
Thanks.
yeah. So just a quick run through for that. Like we have Anna who today for our next session, and she'll be speaking around improving your Java applications in IntelliJ IDEA. So Anna is a software engineer at Itaú Bank, and she hails from Brazil. So that's great. So Anna, now it's all up to you. You can take this forward. I'll just remove myself from this team, and you can share a presentation. And meanwhile, you can show your video as well.
Okay,
Okay.
I'm gonna share my screen.
Okay. Sure.
This one. So let's go. Hi guys. I'm so glad with this opportunity to talk about your Java applications in IntelliJ IDEA. So I love so much IntelliJ, and when we put the corrected configurations and all the tips and tricks, we can improve a lot of our applications and optimize our job. Okay. So let's introduce me. Let me pass it here my slide. So this is my username for all the social medias. And if you have any questions, you can ping me. And let's introduce me. So my name is Anna. And when he said I am from Brazil, just it's for the spoken. And it's my first time with a group from India. So I'm really happy. Here in Brazil, we just 3 a.m., like 4 a.m., but I'm here, wake up. And in Brazil, I work in a big band who calls Itaú Bank. You probably don't know, but we are a Brazilian bank, really big and technological, and using Java, Angular, and this stuff in our applications. And beyond that, I organize some meetups to behind the communities. Well, Makers Code, a big family community that seeks family protagonism through technology. And So Java, in English is I'm Java, but the real name is So Java in Portuguese. And the most big community for users of Java and recognizing a jug. And the Unicorn Tech, we are a community that believes that we can all be unicorns if you believe in ourselves. And I love this slogan. And folks, follow me in all the social medias. Give me feedback after this live, please. And I'm really like this, so let's stop and talk me and let's talk about the team, this IntelliJ idea and JVM. Okay. Oh, let me say one thing. I am really love Java, a lot of Java applications because this I have one tattoo of Java. Okay. So, okay, spoilers of this talk. We are gonna talk about JVM. Why are we gonna talk about JVM? Because Java Virtual Machine is so necessary for our applications, guys. You don't have an idea. And a separating topic is the teams that we'll talk about during this live. And so we're gonna talk about JVM because it's so important for anything we want to do or develop. But okay, no spoilers yet. You okay? We're gonna talk about JVM architecture, memory manager, JVM inside IntelliJ IDEA, me and verify, then properties generated to the files, refactoring, renaming types, Git inside the IntelliJ IDEA, tests, and maybe dependencies. So the test is the only thing that we can pass it, but all the topics we on pass, okay? So let's go. And okay, wait, why I need to know all of this? So I put .vm and all the configurations of IntelliJ IDEA because all my career in the development, I see the necessity to know about all of this. The necessity to configure your .vm, the necessity to know all the tips and tricks that IDEA that you work in. Okay, so it's necessary. Okay. And alert, this talk have concepts for junior, intermediates, and advanced developers, okay? This talks cover topics that can help any level of developer, subjects and tips that have helped me or helped my friends that I noticed. And yes, I love memes and stuff, and this presentation have a lot of gifts, okay? So let's go. The purpose of this presentation is learn together, so leave comments and ask. My English is so okay? So if you have a question and I don't know how answer, please ping me on Twitter that I answer you, okay? So let's go. Let's talk about compilation process. So, so what understand compilation process? Java is a language based in C++, and the compilation have a lot of things that we need to know, such as JVM, garbage collectors, and optimizations of your code. So here in the next slide, we have uh, we have an actor two with the which was the compilation without Java using C++. So here we have this process before Java. We have the code that we type. This called source code, okay? This code just us understand. Our machine don't understand this. And our machine just understand the binary 0 or 1. The process before Java, the process before the Java virtual machine. And because this, there was a different compiler for each one operation system. We let's agree that this takes a long time affecting the delivery of value of the time. So this is spend a lot of time to compilation with code. So this is hard and our team needs to be fast, okay? And now you have a Java. And now we have the compilation uses Java and JVM. In this image, we can see the Java returns one file and .javac or Java compiler, depends whether the font you're reading. This is a bytecode, and the thing is, the JVM, it's one understand this possibility and code polyglot. And folks, this is awesome because turn Java as type of language that is possibility to run on any operating systems. So the code when you download the JDK, we can run almost everywhere because this Java has this slogan: run once, run everywhere. Okay. So before this, you understand the necessity of understand the JVM. JVM is inside all of our application. We saw a talk about Quarkus. Quarkus is awesome, and have JVM inside this too. So understand JVM is very important for any development, and if you coding in one language, probably confirm me, probably this language runs in JVM. I think this language that runs in JVM is Python, JPython, Scala, Clojure, Kotlin, and the stuffs. But before this, what is JVM? Folks, my intention here, deep side the title of the text, not to get you stuck in idea, okay? So, and understand the power you have in your hands when you know the tools you have. That's why we have a JVM. So, let's see this. The first thing to understand is the difference between JDK, JVM, and JRE. I am explaining this difference for you, okay? JDK or Java Development Kit, it was responsibility for compiling .java code for bytecode, and when the process, the responsibility to convert this code is JDK, and JDK is the package when you install with Java the language, and we have a JRE or Java Runtime Environment. It's a It's a Java execution environment in which it provides Java libraries for the JDK to compile your code and the JVM to run your program. And for finally, we have JVM or Java Virtual Machine. It's responsible for executing the .bytecode file and provides our code runs in any operation system. So if you put in imagine, you can see this. Many blocks inside of each other's JDK provides all the things that we use. So I can say when you download the package JDK, you have all the service the Java provides for you. So here you can see JDK, and can JDK have inside of them JRE. JRE is all the things that have the libraries of Java to you, such as method means, labor, libraries, and these stuffs. So Java Virtual Machine is inside of this too. Java Virtual Machine is responsible to run your code and provides the compilation in the end. And this circle of blue, we have the development tools. So let's talk about JVM architecture. So for finally this theory about this talk, let's see what Node JVM architecture can provide for us. So here we have a class loader subsystem, and class loader subsystems we have a lot of. Okay, this one is responsible to receive all the things that say in runtime data areas, and we have the execution engineer here. Execution engineer that has the function of bringing the binaries, and we have the native method interface, a lot of methods that we are development, and native methods libraries, the libs that .er provide for us. And in runtime data areas, we have a lot of times enter and exit, method areas, heap area, Java stacks, PC registers, and native method stacks, okay? So here we have another thing to understand too, is memory manager. When we are coding, we probably do objects, and these objects have a life cycle. And in Java, this life cycle, this is the memory manager, and provides something like this. Memory manager is the heart of development. Inside them, we can optimize a lot of our applications. Here we can see our code have a life cycle. When our code is in young generation, means that all of the objects without the reference, it was there. So objects without reference, a lot of methods, biggest methods, this is in the younger generation. So in the heap area. And before this, when the garbage collector passed and collected all the no reference for your objects, did go to old generation. And before this, the code to compile it with success go to permanent generation, okay? So I think this architecture is about Java 7 or Java 8, but here in Brazil, a lot of our applications is in Java 8 or Java 11, depends a lot, but because this, I use this architecture too, okay? So here we can see the garbage collector in action. So before the survivor spaces and your generation, the garbage collector pans and takes all the no references of the objects and go to the compilation success. So guys, my talk is not so long. My here my object is quick and definitive. So if my talk don't spend a lot of time, I'm so sorry. But we can have so much time to answer questions, okay? But let's see JVM inside IntelliJ idea. So here we can improve .vm properties, JVM options, and memory large. I have an article to explain how to do this in IntelliJ IDEA. You can see, let me share my here key. Isn't there too? This article is in English, but I can translate if you want it. I don't know how if you guys use in dev too, but is a dev community to pull articles about development. And here I have an article who talks about Java VM under the hood and have a step-by-step to how configuration your VM options, VM properties in IntelliJ IDEA. Okay, so this is thing that we wanna do together. Okay, so I'm gonna open my IntelliJ IDEA. I have here a simple Java application using Maven, not Spring Boot, just Maven. And VM properties, what we can improve, okay? We'll go and help this add it help, edit custom VM options, and this action will result in a copy file of .vm properties. After doing this, in your IDE configuration director, you will have a document in the editor that can be changed. And here we have a lot of configurations of the largest memory manager and this stuff. And now we can indeed, in the side of the IntelliJ IDEA, we have all the configuration that is necessary to our application. But here I am going to explain one large for you, the XMX. I don't know how to spell this. Let me see. So XMX, and this guy here, limits the size of the heap that the job VM can allocate it and run on IntelliJ. The default value depends on the platform. If you experience slowness, you may want to increase this value. For example, see to 2048 megabytes, which will be something like this. Okay, if you wanna most biggest megabytes or roaming memory, you can limit it here. Okay, so we have a lot of things to do in VM properties. In my work, we configure a lot of this. We configure the .vm memory because this can optimize our code. And when you work in a big company, you can agree that sometimes your code can be slowly. So you need to know something or things to do your code be more fast. Okay, and you can do this in this source. Okay, it's like Vim options in Eclipse. I don't know how configuration this in Eclipse, but I think it's the same. You just need to find something to edit your Vim properties. When you write the documentation of your IDE, you can see this. Okay, so let's see the another. Okay, I'm sorry. Let's see the another topic. Okay, here I have more theory for you guys. Configuring the VM in your development that is essential for your code to run in a way that doesn't impact anything. So here we have MVN verify. This is so funny. What is MVN verify? It's like an MVN clean and MVN install. We can use in situations of build Java project. It's not a thing. It's not a feature of IntelliJ, but it's a form of build that can help us for improve our applications. Okay. So here I have a simple Java application, and let me put this outside, and I'm opening my terminal, and I'm type mvn verify. That you can see my terminal. So when I type mvn verify, look what I have for answer. The IntelliJ IDEA or my application have a result all of my applications, and this is my build folder, and they have all the answers of my plugins because these applications I put some plugin that MVN can catch. So Meven compile plugin, compile, define comply, my app, compilation here. So mven verify you use it to complete build. No, it's not. It's not means that in mven clean and mven install we can do this, but mven verify can do more things in our applications. Okay, generated. Let me put the slide. Generated. So I don't know. I don't know if you know, but in IntelliJ IDEA we can generate methods, files, and a lot of this. Let's see in my application. Here I have a public class, simple public class. And if I type alt insert in my tag, alt insert, I can generate any code that I want. So I can generate constructor, getter, or setter, or getters and setters, equals and hash code. And if you want to build a REST API, RESTful API, you can generate your endpoint here. So I think it is overwrite method. It's not first methods. Methods to string. And here we have an endpoint for your application. Okay. So this is very fun. It's very nice. Optimize a lot of my jobs when I build REST APIs. Just alt insert generations, my endpoint, and this is so funny. So let's see another tip and trick. To-do files. I don't know, guys, but when you work in a team, sometimes we need to do something to write in our source code to do with another sprint. I don't know. Here in IntelliJ IDEA allows you to add special types of comments highlighted in the editor, indexed hidden and listed in to-do window. When I do this, so when I'm type Control Alt S, we can hear into the file. So we can add case sensitive or don't. We can exclude someone or we can add someone. Let me see, to do list. I don't know. I'm not creative today because it's so late here in Brazil. And we can put in case sensitive. And when you apply this, we can have a to-do file for all the developers watching when they open the source code. Okay. So, okay. And we have a to-do file. And refactoring renames. This is another thing that we can do. We use the rename refactoring to change naming of symbols, files, directories, package, modules, and all the reference to them through code. When you rename methods that are declared in interfaces, you can also review and rename their implementation as well. The refactoring chains are displayed on the refactoring preview tab in the Find Tool window. So let me take you case. When I oil your program, and sometimes you want to rename types or just name it different. And in IntelliJ IDEA, we can do this. Just go in refactor rename. So let me suppose that I need to rename this package. I'm going in refactor rename, and I rename this package. Let me see, application. Funny. I don't know. I'm not creative today. So refactor this. I can refactor all of this. And I am refactor this name. Let me see. Application. You see all the things that have the same name, the change to. Let me see. Control S. This is very nice because sometimes we clone some project and we need to change names, and I don't know, change one by one is so hard, but you can rename all the files. And this is a thing of IntelliJ idea to improve a lot our jobs. So here we have something that I love in IntelliJ idea is Git files. So let me exclude this. I put this wrong. Git, use for the flow. Don't need to install any plugin. So this is very nice. We need to selection you want IntelliJ idea to process passport for Git remote repositories. You need to pass your native keychain. Select these options to use native keychain to store your password. Okay. So here my Git file is already configured, and I need to go see VCS and Git files. Here I can commit any file, and they show me all the files was changed. Here in this case, all these files was changed. I can put the commit message here, engine files, test, and I'm committed this file. I just commit we didn't to reveal. And we type version control. IntelliJ idea provides all the things that we changed, and we have a very explained message of our changes. It's very nice. I have this experience only in VS Code, and when I found this in IntelliJ idea, is so much fun, and I can do a lot of things here. We have a complete resource of our chains, and if I go in my okay here, if I'm going my GitHub, he show me the things that I changed. Okay. If I here, you can build one source file. You here importing to VS Control. You can share your project on GitHub if your projects don't stay in GitHub yet. So this is so much fun. You can do a lot of things. You can use for all these stuffs, and this is very nice inside the IntelliJ idea that some people don't recognize. Okay, so let me in a presentation. We have maybe dependencies. If you create some project from zero, you can add in a dependencies in project structure, libraries, clicking plus, and type the name of some dependence if you need to add and done. So let me think that you need to dependency, and you just don't go to the Maven file, the Maven source. You can do here project structure. You click in plus from Maven, and let me see JUnit. IntelliJ idea found for you all the packages Maven that have the name JUnit. And let's wait something. Gonna wait. Okay. The IntelliJ idea can provide for us all this. Let me search something. Let me see something. Well, this, let me see that we have some comments. So, okay, here we have all the dependencies that Maven can provide for us. If you want something, you just click and okay, and you punch XML. You can have these dependencies all configuring for you. We can add something because, the internet and stuff. So let's wait a little. And IntelliJ idea tells you what app you need to add these dependencies, and this is my app. So let's type OK, apply, OK. And in our pom.xml, we have these dependencies, okay? So let me back here to the presentation. So guys, this is my presentation. I told you that it's not a largest a presentation. My deal here is not take all of your time because I think is sometimes we need to be quick and objective for pass our knowledge. Okay, so if you have some questions that I can answer, you can add me in Twitter or LinkedIn. I am more active in Twitter. And I have my website is annabenetti.github.io, so you can see. I developed me another website. This is old, but you can follow me there too. Okay. So let's keep in touch. So follow me on the social medias and let's learning together. I don't know a lot of things. I saw the another talk about Quarks IO, and I'm thinking, oh my god, this is so good. My talk is not good, such like this, but I think it's okay. All of this, all of them have something to share, and this is a community, okay? So I think that I can share something for you guys. I think that don't have any questions. Okay, you have any questions? I think no. I can see any questions here. But if you have any questions,
Anna, as of now, I can't see any question. But maybe if you'd like to share the learning material links. Uh,
okay. Let me
yeah.
share this presentation. Just a
Yeah.
minute. I'm
Mhm.
gonna share the link. Okay. I'm gonna put here, and you share for the guys.
Yes.
So here we have all you need of this presentation. If you have any questions before this, you can ping me on Twitter. I
Uh,
answer you.
Anna, there is one question. I'll just show
Oh,
you.
let me see how you affection work. Uh, Let me see how you affection work. I don't know. I have a lot of answers for you, but I'm working using Eclipse. I don't know if I'm answering your question, but I'm using Eclipse in my work because we have a lot of codes, oldest codes, and I use Eclipse. But I configured my Eclipse to do all the things of IntelliJ IDEA, and I'm working like this. In Intel, we use GitLab, and we use Jenkins files and this stuff. I don't know, it's a complex, a complex question, but I don't know. I'm working like this, and I don't know. I think his reflection is what I'm working, what I'm doing in my work. I think is this. Understand this.
Uh, okay, cool. Then, Anna, there is one more question which is similar to the same which was asked, like what is reflection?
Yeah, I think I
Yeah.
think Fabrice don't understand the question. The
Hmm.
the the, the type.
Yeah. Okay, then. Thanks a lot, Anna, for your time. And like,
And
it's really late night at your place. Like, it's around 4 o'clock. Is it?
yeah, a kid here,
Yeah. Like,
42
um, yeah,
a.m.
4 p.m. Like, that's really great. Like to see people like you, like waking up late and like doing something for the community and sharing their knowledge and learning. So this is really great, Anna. Like we'll stay in touch, and we'll try to have you for our upcoming live webinars and events as well.
Guys.
So thank you, Anna, from myself and from my team.
So
Looking forward.
I need to thank you guys for the meetup, for the invited me. It's really nice, and I think we're gonna share. I have my communities too. I'm
Mhm,
Java, Teachers Code. Let's keep in touch, okay, guys? Thanks a
mhm.
lot.
Thanks a lot, Anna. And like I can see, like due to the COVID-19 and now this lockdown, at least something has been like really better. Like now people are doing online events, and like this way we can stay in touch with like people who are actually far, like you, because
Yeah,
previously we used to do offline events, and this the uh, for the last few weeks we have started online events, and this is really great. So
yeah.
thanks again, Anna.
Thanks. Bye
Thanks.
bye.
Bye, Anna. So I'll just share my screen for and will show for the upcoming events we are having. Mm, So, guys, as you can see, like uh, so we are from CodeOps and Confirm. So we do regular meetups and conferences, basically tech conferences, and also various developer related events. So currently we have started one of our developer event, which is called Azure Developer Stories, for which we are encouraging developers, like professional developers, to write and share their knowledge on Azure by writing a blog. So this is one of the coolest thing we are doing right now, and we have like great prizes for the winners. So please take a look on the website of our contest. I'll share this link. uh, Here you have how it works, like what are the things has to be mentioned in your blog, and like how to submit. We also have learning materials. So I'll just quickly show you that. We have learning materials which will run through you through the like learning materials of how to get started with, and like there are sample blogs on different categories which you can use. There are reference blogs and tutorials. All those cool stuffs are here. So it's a one-stop place for you to get the knowledge about the contest, and like so I hope like people will be contributing for this contest, because this is for the community and we are encouraging developers, which will help other developers and people to get to know about Azure, how are they using Azure, and how they're making and building cool stuffs over there. One more event I'd like to show. So this is one of our upcoming online mini conference. This is on 30th of May, and this will start from 11 o'clock. We have cool speakers. So we have Arvind from Elastic. We have Ritesh Modi, who is the regional director of Microsoft. Then we have Hank. So we have really cool speakers and cool lineups. You can go through the agenda and you can register yourself for the event. These are all free events. So I would like to say, like, go through these events and like learn as much you can, but this is the time when you are sitting at your home and you can explore new technologies and what's going around. So this is there. We have one more event, which is the big short event we are coming up with. It's called Cloud Community Days, and it's a 3-day conference starting from 17th of June, 17th, 18th, and 19th. It's totally free and it's online. So this event is totally focused around cloud and cloud native technologies. Then we are partnering with so many communities and we are encouraging developers to come and join us for the conferences. We have 15 experts. We have few of the speakers lined up here already. Like as you can see, like Kamesh was one of the speakers for today's live event. He's also gonna be there. Also, if you would like to propose your talk and want to speak at the conference, then you can apply it here through the CFE form. For the 3 different days, we are following 3 different themes. On the first day, we'll be following cloud native. Then the next day, we are going to focus on AI and ML. Then we are having serverless and DevOps. The agenda will be live soon, and this is all. So I'd like to tell this to all of you, like, join us, learn as much as you can. So thank you all. Thank you all for joining us for the live webinar we had today. And I hope all of you will be joining us for the upcoming events also. Also, if you want to give a talk at one of our events or meetups, please reach out to us. I'll be sharing the social media links where you can see all our activities and reach out to us for speaking opportunities. Thank you all. Have a good day.